Okay, now we're moving on to dividing polynomials. Okay, if you notice, all our sets of terms are already divided up into parentheses. If not, I wouldn't be dividing the whole thing by x minus 3. If that parenthesis wasn't there, it would be just divided by x and then subtracting 3 at the end. So those parentheses are important. So let's just look at it. Set it up as a regular division problem. So you have x squared plus 2x minus 12, and you're dividing it by x minus 3. Remember when I was talking about this, I said you always just worry about the first thing that you're working with. You're working with x and x squared. So you're starting at the left, working left to right. So that being the case, how many times does x go into x squared? Okay? What do I have to multiply x by to get to x squared? By x. So then you multiply that x times x, I'll give you x squared. Now don't forget your minus 3. What's x times negative 3? Negative 3x. Now you're so used to doing log division that you forget that you're actually subtracting this whole part. So you're subtracting it from it. So what we need to do is we just need to go change the sign. So it becomes minus x squared, and negative times a negative is plus 3x, isn't it? So now we can go and we can subtract it. X squared minus x squared, there's nothing. 2x plus 3x is 5x. Once again, go back to only looking at the first terms. I'm still working with our divisor of x, and now our first term is 5x. What do I have to multiply x by to get 5x? Well, that would be a positive. Oops, let me undo that one. That would be a positive 5x. Excuse me, not 5x, 5. So we have our positive 5. So 5 times x is 5x. 5 times 3, negative 3 is negative 15, isn't it? But now, let's bring down our negative 12. But remember, we're subtracting 5x minus 15, so you have to change all the signs. So it's negative 5x plus 15. 5x minus 5x, we got rid of, and negative 12 plus 15 is 3. This is our divisor. I assume here. What we're left after dividing, this actually becomes our numerator over our divisor. Remember when you did math and you had 2 goes into 15, 2 goes into 15 7 times, 2 times 7 is 14, your remainder was 1, so it became 1 became your numerator, 1/2. We're doing the exact same thing here. Our remainder becomes the numerator, our divisor becomes the denominator. Let's look at our next problem. Let's set it up, and we're going to set it up just a little bit different this time, because we jump all the way from x to the 3rd power all the way to something with the 1st power. So you know what? We're going to need to put placeholders in there. So we're going to start with x to the 3rd. And then we have, you can put 0x to the 2nd, right? Plus 0x would be x to the 1st, plus 1. You need to put placeholders in there for this. And now we are dividing it by x plus 1. Once again, we are just looking at our first terms. What do I need to multiply x by to get x to the 3rd? That would be x squared. I really like that yellow. So that is x squared. So x squared times x will give us x to the 3rd. What's x squared times 1? Well, that's just x squared, isn't it? Now that you've set it up, remember we're subtracting all of these. So we need to switch all of the signs, and this will give us x to the 3rd minus x to the 3rd is nothing, and x squared minus negative x squared, that's a negative x squared. So what do I have to multiply x by to get negative x squared? Well, that would be negative x, wouldn't it? Let's bring down our plus 0x. And so now it's going to be a negative x, isn't it? Okay? gives us negative x squared. Negative x times x is negative x squared. And negative x times 1 gives us negative 1x, doesn't it? Now, once again, we're subtracting, so we need to switch all the signs. So x, negative x squared, positive x squared, that goes away. That leaves us with x plus, bring down the plus 1. How many times does x plus 1 go to x plus 1? 1 time. I know this looks confusing, but it's not. It's just a matter of it taking slowly, step by step. Sorry this was a little rushed. Terrible technical difficulties today. But break it down. It is a division problem. I've always talked about it. You just make sure that you're working from the far left. The far left of your divisor and the far left of your dividend. And that's where you work, and then everything else just follows. I did the examples in the book, so if you need to go back, the book does a great job of going through those examples. What you're going to do now is you're going to do all the try this, A, B, C, and D, and then your homework tonight, I'm going to make it light, you have the other page, plus you have 467, 2 through 28 evens, and that will be it. Have a good Tuesday. I'll see you all on Wednesday.